Hi everyone, and welcome to this MeaningCloud webinar, where we're going to present an introduction to text analytics. We'll be talking about text classification, information extraction, sentiment analysis, about how they are different and when we should be using each one. So my name is Antonio, and I work in marketing at MeaningCloud. And I wouldn't like to be the only one talking today. We look forward to your participation, comments, and questions. And you can do that in several ways. You should be seeing a GoToWebinar panel like the one on the slide on your screen. And you have a couple of possibilities. First, you can use the chat feature of the panel, which is this one, and send us your question at any time. And also, at the end of the session, we have reserved a Q&A time. So if you want to ask your question by voice, you just raise your hand using this button in your panel, and we'll enable your mic and we'll be able to hear you. As always, we are recording this webinar and we'll make it available for you via our blog, so stay tuned to our emails and blog. So essentially, the purpose of this webinar, as I mentioned, is to learn what the main text analytics functions are and what they can do for us. So this is a somewhat introductory session. The reason we are giving it is because many of you asked for it. In fact, this is a recurrent request in our support line and in our conversation with you. So you asked for it, we delivered. And how we plan to deliver that? Well, this is the agenda for our session. We'll begin with a short introduction to text analytics that may be useful for some of you who may be totally new to it. Then we'll give some context about application scenarios, which are the most typical for text analytics. Then we'll go to the core part of the session, which is text analytics functions. We'll be describing those and demonstrating those using MeaningCloud or product, and describe some use cases. Then we will be talking about the quality of text analytics tools, how you can measure it, and most importantly, how you can improve it. And finally, we'll take a look at the future in MeaningCloud roadmap, talking about some features and functions that we will be delivering in the coming months. And finally, some conclusions and Q&A time. So, why should be using text analytics? Well, the fact is companies and organizations are discovering that more and more useful information is hidden in an unstructured content like documents and records or contact center interactions. And in fact, for example, social media and other sources are creating an explosion of unstructured text. And some analysts say that only 20% of the useful data for organization is structured and stored in databases, which leaves the remaining 80% of information for unstructured content. And also, unstructured is growing more rapidly than structured data. The problem is that this content is not easily processed by automatic means, and computers have some difficulties in understanding it. And this is where text analytics come in. So text analytics essentially are a set of tools and technology that are able to extract meaning and actionable insights from unstructured content and help us automate some costly manual activities. Text analytics uses a mix of technologies like natural language processing or machine learning to be able to take a free-form text and extract elements of meaning from it. Elements like, for example, mentions of people or companies or brands or organizations, or abstract concepts, or for example, themes, facts, opinions, and relationship among those. So essentially, these are elements that can be used to structure the text and to better understand the text. So when you begin to dip your toe in the water of text analytics, you find this set of functions like information extraction or name entity recognition or categorization or clustering, sentiment analysis, each of those performing a different text analytics task. And the questions now are, what are they for, when to use them? And this is the subject of session today. So let's begin by giving some context, talking about application scenarios for text analytics. This is not meant to be exhaustive, but only a reminder of the most frequent application of text analytics. I'm sure some of you are developing some really innovative uses of text analytics, and in fact, some of them are even unexpected to us. And also bear in mind that these are not separate categories. You'll see there's some degree of overlapping among them. So let's go to the first one, social media analysis. And basically, this is the possibility to analyze massive data from social media and to understand the conversation in places like social networks, blogs, or forums. For example, a typical application is doing some brand and reputation monitoring, but also, for example, detecting how a social media user relates to our brand and our company, if he is considering a purchase, or he has bought, or if he is a satisfied customer or an unsatisfied customer. In general, being able to detect his intent and to understand what is called his customer journey. Or for example, we can aggregate information around a specific user and be able to profile him in terms of demographic, attitudes, and lifestyle attributes. Also, we can use text analytics to analyze user-generated content, for example, to detect trends and themes, to leverage this content, or, for example, to moderate conversation, trying to avoid inappropriate content. Also, a big subset of this is the counterterrorism application for security and defense purposes. And obviously the challenge here is the characteristics of the language used in this context in terms of informal or grammatically incorrect language that poses additional difficulties to the analysis of text. Another application area which is very extended lately is what has to do with the analysis of the so-called voice of the customer and the management of the customer experience. And this has to do with the rise in unsolicited or unstructured feedback sources. For example, comments in surveys or interactions in the contact center or social conversations. So the idea is to enrich the data that we already have about our customers with these non-traditional sources to create an integrated and 360-degree view of the customer. So this integrated view serves us to better understand our customers, to detect their needs, their product preferences, and in general to create customer experiences that are more personalized, more consistent, and more relevant. So another application area that may be considered a subset of the previous one is what someone called the voice of the voice of the citizen or voice of the voter, and in general has to do with government, either national or regional, with political parties, etc., and has to do with the opinion mining and trend detection concerning the political or economic situation, the government, and the services. At MeaningCloud, we've been able to develop some very specific and interesting cases about the voice of the customer, for example, related to the emergency situation management. We've been able to monitor social networks for the early detection of emergency situation, like, for example, traffic accidents or floods or demonstration or riots, etc. And also we have been able to aggregate multimedia information that has been shared in different social networks to create a record about the emergency, kind of story of the emergency that serves to early detect and understand and better respond to it. Finally, another version of the voice of application scenario has to do with not with external customers or citizens, but with internal people like employees. It's what we call the voice of the employee, that is part of the, in general, people analytics application area. So in this case, we're trying to improve the understanding of our workforce. We analyze information sources like internal surveys, performance reviews, exit interviews, resumes, email communications, etc. For example, for not only trying to assess the work atmosphere, but also to understand what is the reason behind those scores. Also, for example, to understand what attitudes and skills and behaviors are the most present among the top performers, or to detect how likely is that a given employee leaves the company, or what are the main reasons for attrition. So this kind of analysis allows the segmentation of employees according to attitudinal and professional dimensions for an improved workforce comprehension. And this enables an effective talent management and improves the employee retention. Another big application area for text analytics is what is called intelligent content or semantic publishing. And this is targeted at media and, in general, content publishing companies. It has to do with making your content more findable, reusable, personalizable, and monetizable. So the idea is to semantically tag all your content, your articles, your books, your news, etc. To, for example, better understand your archive, or, for example, when generating new content, being able to relate this content to other content, to enrich with external content, and to relate to other pieces of content, and improving the quality of the content that we are generating. Also, this enables us to better engage our audience, because we can present them with personalized content to recommend related content to what he usually consumes, or to offer content related to specific topics. And also it enables us new ways for monetizing the content because we can more easily distribute, syndicate it, and also to present contextually targeted advertise. Finally, we are able to moderate and understand, as I mentioned before, the content that users generate in our web properties. Another very related application area is what has to do with knowledge management. And this is targeted at knowledge-intensive industries, like, for example, consulting, or knowledge-intensive functions inside the company, like R&D, for example. So the idea is to tag the documents that you have about previous situations or customers or project or experiences, so that you can leverage the tacit knowledge hidden on those documents. So advanced semantic tagging and analysis enables you to do very advanced retrieval and exploitation of your documentation base. And finally, another application scenario has to do with e-discovery and regulatory compliance. And this has to do with legal processes and regulations. For example, imagine in a legal proceeding, the judge or some other authority may ask us for information related to some specific situation or theme. Or in regulated industries, like, for example, financial services, regulators are more exigent about communication surveillance to prevent situations like, for example, insider trading or market manipulation. So the idea here is to analyze documents or phone call transcription or email or even chat or social, trying to detect specific patterns. And the low latency associated with these treatments enable us to prevent criminal behavior, for example, or also to give a quick response when an external authority asks us for specific information regarding our activities. So this ends the summary of the application and scenarios that typically appears in text analytics. I'm sure many of you have more innovative and original scenarios, but this can give us some context for the description or the text analytics functions that we're going to do now. So we are using our product MeaningCloud to explain this part of the session. I know most of you are familiar with MeaningCloud, but for those of you who aren't, MeaningCloud is our product for meaning as a service. Essentially, it's a set of text analytics APIs that we have published in the cloud and are available for you to directly use into your application and systems. Also, there's the possibility to install our software into your infrastructure in an on-premises mode. And we have a free plan that all of you can use to play with the product and experiment and evaluate it for your purposes. So if you haven't done so, I suggest that you go to meaningcloud.com and register for a free account. So essentially, MeaningCloud, as I mentioned, offers a set of text analytics APIs. These are the APIs that are presently generally available. These are RESTful standard-based APIs for different purposes like information extraction, categorization, sentiment analysis. We'll cover that in all of them in a minute. All of them have developer tools that enable to use the APIs within the most popular programming languages. They are well documented, and also they include a test console that enables you to explore the API in depth without programming. It's a web interface that you can use to do API invocations without creating a program. Another interesting thing about MeaningCloud is that we have tried to make the product accessible to data analysts and non-technical users. And towards that, we have created an add-in for Excel, for Microsoft Excel. You install this add-in in your Excel, and you can you can call most of MeaningCloud functions within Excel. You paste your text in an Excel spreadsheet, and you press a button, and text go to MeaningCloud, is analyzed, and the result of the analysis is presented inside an Excel spreadsheet too. Like, for example, this window is the result of a sentiment analysis. So you don't need to program to use the APIs in this mode. And essentially, Excel is the most convenient way to evaluate and to prototype and to use MeaningCloud. So let's go for the different APIs and see what the different text analytics functions are. First one we're going to cover is the topic extraction API, that for us is information extraction. Essentially, this API detects appearances of brands, companies, organizations, people, places, things with a proper name. Also, it detects concepts like abstract concepts, common names, and makes that in a very sophisticated way. For example, in this example that you have on the slide, we are able to detect Tim Cook as a person who is the Chief Executive Officer of Apple. We detect several appearances of the same person under different variants, for example, Cook, Tim Cook, etc. Thanks to our contextual disambiguation capabilities. Also, we are able to identify Apple in this context, as a name of a company, not the name of a fruit. And we also detect things like monetary amounts and specific concept, like, for example, charity in this case, which is very relevant in this specific piece of text. So let me show you how this works in MeaningCloud. The best way to demonstrate that is go into our web demo. This is totally open. Okay, you can use this demo without even registering to the product. So for example, I can paste a text here. I'll paste this piece of news about the Rio Olympic Games and the role of Simone Biles in it. Okay, I'm pasting the text and sending to the APIs, and the result is shown in this screen. We have several tabs here. And the first one is entities, which is, as I mentioned, things with name like people or organization or companies or brands or places, etc. For example, you see here it has detected Simone Biles under different variants, Biles, etc. Also an event as the Rio de Janeiro Olympics, appearing also under different names. You see, along with the type of entity, the system returns some additional information, like, for example, data from external sources like Wikipedia or linked data sources that enrich the information that the system provides about a specific entity, or, for example, in the cases of cities, again, or Russia or London. Okay, it also has detected some other people names. Okay, and also it has detected abstract concepts, common names that can even be multi-word expressions. You see, we have detected gymnast or world or food. Okay, and most interestingly, for example, silver medal or gold medal, that are multi-word concepts with a specific meaning and related to sport, for example, and that has a different meaning than gold or medal. Okay, and also we are able to detect some other topics like time expression, like dates, money expressions or quantity expressions. We are able to detect the numeric value and the unit in which they are expressed. So essentially, this is the how text topic extraction API works. The base for the API is an internal standard ontology that MeaningCloud includes with different entities and concepts. For example, if we go to this page in our website, we can navigate the ontology. Okay, for example, you count these entities, organizations, companies, etc., etc., etc. You can navigate our ontology, and this is pre-built into the system. And one of the most interesting things is that you can also expand this ontology and customize the ontology with your own dictionaries made of entities and concepts relative to your domain. We'll talk about that later. So what is topic extraction for? So essentially, it is good when you need to do a sophisticated detection of any appearance or mention of brands, people, companies, concepts, etc. Sophisticated in the sense that we made a context-aware disambiguation, we cover co-reference, etc. So this is useful, for example, in application like keyword extraction, or, for example, to annotate pieces of content like news or books or emails or records. For example, we can annotate a medical record with the name of the specific diseases or treatments that are involved in this record. Or, for example, we can do some social media monitoring for detecting brands, product, competitors, etc. And also in voice of the customer, voice of the employee, etc. environments for detecting which product are they talking about, which attributes are they talking about, etc. And also, for example, for user profiling purposes in terms of what interest a specific user has, which brand or product is he talking about. Then we have the text classification API. And the best way to describe text classification is using a metaphor, the metaphor of a file cabinet with drawers, each one with a predefined tag. The tag specifies the theme of the documents that I'm going to store in it. So essentially, text classification takes a new document and decides on which drawer we should put this document. Okay, so in general, we start from predefined taxonomy, which is a set of categories, a hierarchy of themes if you want, and use different technologies to classify according to this taxonomy. For example, this piece of text, we are classifying it using a standard classification model, which is the contextual IAB taxonomy for advertising purposes, and I'll cover that in a minute. And according to this taxonomy, this text belongs to the categories sport or soccer, travel, Europe, etc. Each one of them with a specific relevance that describe the adherence of this document to each specific category. So again, MeaningCloud comes with a built-in set of standard categories. For example, we use IPTC for classifying news, IAB for contextually classifying content for advertising purposes. We also have some other categories like Eurobug for public administration activities, and some other proprietary categories for social media, and more of them that are in development, and I will talk about that in a few minutes. So let's see how this works in practice. I'm going back to my Simon Biles example. I'm going to the Disclassification tab. You see I have classified this according to the IPTC categories taxonomy and the IAB taxonomy. According to the first one, that is news related, as I mentioned. This piece of text has to do with sport, gymnastics, and sport in general. But according to IAB, which is a different view of the world, if you want, this piece of text has to do with exercise and Olympics. Okay, and each one of the cases has different relevance. I'm also using this text analytics functions to show you another way of interacting with the system, which is the test console. Okay, so as I mentioned before, this allows me to invoke the API without programming. So let me paste the text here. Just, you see, selecting a model, which will be IAB for English. Okay, and clicking here. So you see it gives me the same results than the web demo, exercise and Olympics. And the difference here is that I can here twist and play with the parameters in general and the different input format of the API. So going back to our presentation, it's interesting to note that in MeaningCloud, we are using a mix of technologies for categorization. Most of vendors in our space use a machine learning approach in which you give training documents for each category and the system learns to classify. But this approach has some limitations, and we have complemented it with a rule-based approach in which you define specific rules that must verify the documents in each category. So this enables us to give the classification an increased level of precision. So what is text classification for? In general, is for scenarios where you want to do a theme categorization in which the category is inferred from the whole content. for example, the text is similar to other text belonging to the category, or the text verifies certain rules. But in general, you don't need that a certain term explicitly appears in the text, like, for example, in information extraction. So you can use text classification for essentially the same kind of application as information extraction, to annotate documents, for detecting themes in voice of the customer feedback, or to analyze social media, but with this slightly different perspective of theme classification and not information extraction. It's interesting to note also that in MeaningCloud, along with the standard built-in classification models, we provide the possibility of creating your own models customized to your domain, and we'll cover that in a minute again. So another interesting API is text clustering, and this is similar to text classification in the sense that you assign a category, if you want, a topic to the document, but the difference is that you don't need to start from a predefined taxonomy. Okay, so essentially you take a collection of text, and the system is able to detect what topics, what meaningful themes emerge from the collection of documents, to identify those, and also to group the different documents around each of those meaningful things. For example, in this case, we found a theme, financial crisis, and another which is greenhouse effect, and we aggregate the document that has to do with the first theme and the other. Okay, so the result of the API will be something like this: the size of the cluster and the documents that belong in this cluster. How do you use text clustering in practice? So this API, this specific API is not covered in a web demo. So I'm going to use this opportunity to present the add-in for Excel. So essentially, you see I pasted here sorry, several comments about hotels in a hotel survey site. And I have this MeaningCloud ribbon that gives me access to different APIs like text classification or topic extraction, in this case, text clustering. I'm going to use that. Okay, I select the range for the evaluation, the language, English, etc. I analyze. So it has sent the documents to MeaningCloud, text clustering API, and the API returns a set of clusters with a name, with a specific theme for each of those that represent meaningful topics in the document collections, like, for example, beautiful or shower or dinner or hotel staff. And you see it has tried to assign one of several clusters to each document. For example, in this specific comment, you see it appears repeated several times because it belongs to 4 of the cluster it has detected. The clusters, we can use this to filter. Okay, you see are each of this one. Okay, and also it assigns a score to each cluster that represent the relevance to this cluster in the document set. Okay, so what is text clustering good for? So in general, is when you don't have a predefined taxonomy, text clustering enables you to group text by similarity or to discover these themes inside the document collection. Applications examples are detection of duplicates in a collection of documents, or for example, discovering the structure that emerges from the document collection, or in social media analysis, for example, the discovery of conversation themes in social media. And another interesting use case is in voice of the customer scenarios. We've been able to use text clustering to discover what our customers call the new voice of the customer, meaning specific themes or categories that our customer didn't have on their radar, okay, but represent meaningful things that they need to monitor. So another API, very interesting, very useful, is sentiment analysis that has to do with opinion mining. And the idea is to detect the polarity of opinions of a fact that are expressed in a document, both as a document level and also at an attribute or aspect level. So we have, for example, in this case, we're talking about different attributes of a hotel, and the sentiment analysis API give us the polarity about each specific attributes. For example, the landscape, which are amazing, is positive. The rooms are negative. And also it aggregates the polarities to obtain a general polarity. In this case, both polarities compensate each other, so the aggregate polarity is neutral. Also, the system found a disagreement because polarities have different signs. And also it detects the type of language used, whether it's subjective or objective, meaning it expresses opinion or a fact. And also we have in beta an interesting functionality for irony detection. How this works in reality. So let's go to our Simon Biles demonstration. So in these sentiment tabs, we have the general sentiment, which is positive. Also, it finds some disagreement in polarities and the type of language detected. And along with the general polarity, it gives the feature level sentiment related, for example, to entities. You see here it has found some entities for which the polarity is positive. Okay. Some others have no polarity associated. And again, for the concepts, it has found some of those where the polarity is positive and other with a neutral polarity. So what is sentiment analysis good for? In general, in opinion mining applications, okay, like for example in social media monitoring, when you need to understand if people is talking about you in positive or negative terms, and also in voice of the customer environments where people is talking about your product or your service, and you need to understand what product attributes or service attributes are well considered or not. So a Couple of last APIs. First is the lemmatization and past-over-speech tagging API, which does detailed morphosyntactic and semantic analysis of the sentences. It gives you a syntactic analysis, lemmas, a complete part-of-speech tagging. Also find a grammatical relationship like subject, verb, object, etc. Also finds quotations, and just to give you a flavor of how it works, let me use this specific sentence. I'll go again to my APIs, going to the lemmatization test console. I'm going to ask for a documentary chart in English, yes. So you see all the parameters in the API. Okay. So this is the result of the morphosyntactic analysis of this sentence. You see all the words and segments has been tagged, and also very interestingly, for example, when this he pronoun appears, sorry about that. It realizes that he is referring to the same Mr. John that appear on the first part of the sentence, in this case of anaphora. So this is the result of the morphosyntactic analysis. And what this is good for? Well, first of all, it's useful for text proofreading applications. We have implemented that for several customers. Proofreading at spelling and grammatical and style levels. And also we even have published a specific product for text proofreading, which is Stylus. It works for Spanish, and you can use it for free if you go to mystylus.com. And also this kind of morphosyntactic analysis can be used as the support for the detection of semantic relationship. For example, you want to detect if a company has invested in some other companies. You can mine news outlet looking for this kind of information. And when you have a specific sentence grammatically tagged and also the semantic information extracted for this sentence, you can now understand that the sentence is talking about this specific kind of relationship and identify this specific content. Okay, and finally, last API that we have in beta. If you want access, just let us know. Is the user profiling API that enables you to use the content that a user publishes in social media and the description in his social profile, and is able to extract different demographic and psychographic attributes like the person or his an organization, the gender, the age, the location, the occupation, the brands that he mentions more frequently, some lifestyle attributes like he's married, not, he has a dog or whatever. So this kind of information we can extract from this API. I'll show you that in practice. So this is the user profiling test console. Okay, it has several mode. In this particular, which is Twitter handle, I need to identify a specific Twitter user. This guy's my boss. and I give the API some Twitter credentials so that it can access the Twitter APIs on my behalf. Okay, so the API will go and fetch the profile of this person and the 100 latest tweets, and try to extract some profiling information about this specific user, like for example his age, the banks that he mentions, the city, continents that he mentioned, his gender, the type of language that he uses, the industry in which he works. ICB is a standard classification for industries. In this case, is technology. The sports that he relates to, the other topic and subtopics that he talks about. For example, his occupation using a standard ISCO taxonomy. ISCO 1 is the category for CEOs, for example, etc., etc. So what is user profiling useful for? Essentially, when you need to understand your audience or your market, you need to profile and segment your audience, or for example, some users are using it for analyzing communities in social media, or for example in influencer marketing to profile your influencers. So this pretty much finalize the explanation of text analytics functions and use cases. Next, I would like to cover quality in text analytics. Because we all understand that text analytics is not perfect, and like other artificial intelligence based technologies, it sometimes makes mistakes. So the question is, how can I measure text analytics quality, and most importantly, how can I improve it? So the first concept that comes to our mind when we think of quality in this context is precision. What percentage of the things that I detect are correct? And for example, is a 70% precision good enough? So the first thing we need to consider is that even human experts aren't 100% precise. If you analyze a document with human experts, you only achieve 85–95% agreement. So the perfect precision is impossible. And also, along with precision, another measure of quality which is very important is recall, which is how many things I am able to detect. Do I miss something? For example, in this picture, you have an example in which I'm trying to detect the green documents, and the documents that my algorithm identify are the ones with this blue frame around them. So you see in this case, for example, you are not missing any documents, and all the documents that you detect are correct, are green, so you have high precision and high recall. But for example, in these other cases, you have low recall because you miss many green documents, but high precision because all the documents that you detect are green. And in this third case, you have high recall because you don't miss almost any green document, but unfortunately, many of the documents that you detect are not green, so your precision is not low, is low. So another thing to consider is that precision and recall are inversely related, because for a given technology, when you increase precision, you do that at the cost of lowering recall, and And the opposite is also true. If you increase recall, you lose precision. But at the end, it all depends on the requirement of your specific application. For example, for brand monitoring purposes, you can go with low recall. You can miss some comments, but you need high precision. But for example, in a counter-terrorism application, you don't want to miss anything, so you need a very high recall, but you can afford some precision that is not perfect and get some false positive that you can screen later with some human implication. So how can I get extremely good accuracy with text analytics? So along with the quality of your algorithms and your underlying technology, there's a sure way to improve the quality, and it's using a specific linguistic resource for your domain. For example, imagine you're analyzing a bank customer opinion. So you need to detect the mention of your specific banks and products, and also you need to classify according to themes that are specific to your industry, for example, about your product categories or your channel for contact with the customers, like office and phone and internet. And also you need to consider the subtleties of language in your domain when you're analyzing sentiment. For example, you can say the highest interest rate in an industry, and depending if whether you're talking about savings or talking about mortgages, the opinion in this sentence can be positive or negative. So ideally, you need to have ways to adapt your text analytics APIs to these specific scenarios. The good news is that in MeaningCloud we provide the technologies to the tools to really customize your ontology, your classification models, and your sentiment models via some end-user tools that have a graphical interface and enable you to really adapt and customize the APIs to your domain without programming, and so improving the precision and recall of your system. And if you're interested in this kind of tool, you can follow that link and go to a recorded webinar that we gave some months ago about customization in MeaningCloud. And finally, a view into the future with some features and functions that we are releasing for MeaningCloud the coming months. For example, if you are a RapidMiner user, which is a very popular data analytics tool, you'll be glad to know that we plan to launch an extension that will enable to combine the data analytics in RapidMiner with the text analytics in MeaningCloud. Also, we plan to deliver new languages and to launch new APIs for document summarization and parts of document detection. And we need to, and we plan to also launch some vertical packs that are pre-built dictionaries and classification models and sentiment models that enable you to do a very precise treatment of several applications, like for example, voice of the customer in general, or voice of the customer for several industries, or voice of the employee, or health. We have developed health vocabularies with hundreds of thousands of entities and concepts that really enable you to understand the language in medicine and healthcare. And also we plan to launch a insight extractor, which is a new tool to categorize and do information extraction in a very fine-grained way, and using some really innovative models based on semantic rules. So finally, as a conclusion of the webinar and before going to your questions, there are tools, text analytics tools that really enable to turn your text into insights. The application scenarios are countless. I am sure some of you are now defining some of the future scenarios for text analytics. You can really obtain a high quality in the analysis by means of customizing the system to your specific domain. And finally, if you're considering to the use of text analytics into your application or your system or your business model, MeaningCloud, we are a specialist in this field. So I'd suggest that you let us do the heavy lifting in text analytics and you focus on your business and your specific applications. So that's it from my part. I would like to see if there are any questions. Okay, let me see. There are many of them. Okay, I think my colleague has answered some of the questions. A question about the RapidMiner extension. Yes, we plan to launch maybe in 3-4 weeks. Let me see some of the questions. Yeah, some people ask how many languages are included in MeaningCloud right now. We currently treat Spanish, English, French, Italian, Portuguese, and Catalan. And in the coming months, we have, as I mentioned, Russian, Chinese, and Arabic. And later this year and beginning next year, we'll be launching maybe 10 more languages. Okay. Also, some people are asking if we have academic licenses for R&D project. In general, yes, we try to foster the use of MeaningCloud in R&D and academic projects, and we're willing to give you priority access to the free service. So just send us a letter and we'll be able to set up for you. Now a question about whether the API is able to work with things like Tableau, for example. Yeah, we're able to integrate the APIs with Tableau and other graphical or an analysis application. Take into account that the results of the API are JSON or XML, so you can use this XML and JSON to store in a repository and to make it accessible to Tableau onto other applications. Okay. Let me see. Okay, I think we have answered most of the questions now. So as a last word, just to remind you that we'll soon be publishing the recording of the webinar in our blog, and we'll send you an email announcing that, and also a tutorial about Text Analytics 101. So stay tuned to our emails and to our blog. And nothing else. It's been a pleasure having you, and see you in the next MeaningCloud webinar. Thank you.